So here is another application of derivative, which is marginal values in production. So here, let's start with the revenue side, the benefit side. Marginal revenue is the change in total revenue for producing one additional unit of output. So as you can hear, this kind of keywords should echo in your mind. One additional unit, right? That means the unit in the margin. And here, how this unit in the margin cause your total revenue to change. That is the concept of derivative, right? So it's the change of total revenue per each additional unit produced. So here are several keywords. One additional in intuitive terms, okay, and marginal in business terms, and slope of tangent line in graphic terms. So they both tell you one thing, which is derivative. Okay. And here, then in terms of cost, marginal cost is the change in total cost for a change in quantity. For a change in quantity, namely it is for a change for additional unit product produced, right? And this can also be found using the first order derivative. So here is one thing. You should note that Q is the independent variable because this is a variable that firm can decide on, right? You cannot dictate the market to go with a certain price, and you can hardly influence the minds of the buyers, right, to accept a certain price. But here, what you can do as a tool to change the market price is by the availability of the products, how much to produce, right? So Q is under your decision as firm, right? And then everything should be written as a function of Q. For instance, here, price is written as a function of Q, right? And the cost is also written as a function of Q. So here, what are the marginal cost and marginal revenue? In order to calculate that, let me quickly switch to my document camera again. So here is 3 to 4b marginal values. Okay, so here in this question, what we have is E equals to 110 minus 2Q, right? And here, this is prices on the revenue side because total revenue is price by quantity, right? That is 110 minus 2Q by Q is 110Q minus 2Q squared. And then marginal revenue is just the derivative of total revenue with respect to Q. So that is 110 minus 2 times of 2Q, right? The derivative of Q squared is 2Q. So it's 110 minus 4 times of Q. So that is the marginal revenue. And then to the cost side, so fixed cost is 100. Variable cost is 2Q squared plus 10Q. So the total cost is fixed cost plus variable cost, which is 100 plus 2Q squared plus 10Q. And then marginal cost is how much total cost change per each additional unit of output produced, which is derivative concept. So here, what we are going to do is to take the derivative. The first item, we just disregard because that's a constant. The second one is 2 by 2Q. Again, the quadratic's derivative is 2Q. plus 10, because here it is a linear form, right? 2q itself is a linear form, then the derivative is just a slope term. So here, the marginal cost is expressed as 4q plus 10. So those are the answers to this question. So now let's switch to the graph. So here, if we do have a bunch of graph, so now I hope you can utilize marginal cost to tell the growing trend of total cost. All right. So for instance, here, as you can see, the marginal cost is always positive. So here, that indicates that your total cost should be constantly growing. Is that constantly growing in the graph above? Yes, it is traveling northeast, right? Then when here before unit 4, the marginal cost was decreasing. That means your increasing trend should be decreasing, right? So previously it was increasing very fast, and then the slope of tangent line to each point is getting flatter and flatter, right? So that tells you before unit 4, actually the total cost exhibit a pattern of concave function. And after unit 4, as you can see, the marginal cost is increasing. That is to tell you the growing trend is becoming more and more rapid. So that is basically a feature of convex function. So after point 4, we see it's growing, the total cost is growing more like an exponential pattern. So here, this is how we utilize marginal cost to help us, again, to graph the picture, to draw the graph of total cost.